I see. I hear. I touch.
Hi, I'm Dr. Heather Culbertson, and here at USC, I direct the HARVI lab, which is the Haptics, Robotics, and Virtual Interaction Lab. We're really sad that you're all not able to come visit us in person this year, but we wanted to put together this short video to describe our research and what we do here at USC. So here in the HARVI lab, we deal all with the sense of touch. So as you know, we have 5 senses, which are, sight, hearing, smell, taste, and touch. So as you probably have already thought about how much you rely on your sense of sight and sense of hearing in your everyday life, but the sense of touch really is an underappreciated sense of based on how much you actually use it to do everyday tasks. So I always love starting out showing this video that I really think clearly illustrates how much you rely on your sense of touch. So first, the person is showing doing really simple task of lighting a match, really, really easy to do. And then they anesthetize their fingers, make them really numb. And we can see that it's really difficult for her to even pick up the matches. Okay, so it's really challenging to do, almost painful to watch her do it. And so she can still see the matches, can still smell the matches, could still taste the matches. And the only sense that's missing now is touch. And so if you've ever so she finally gets it lit, but it takes a significantly longer amount of time. So the same thing happens if you've ever, sat on your arms, flopped on it weird, and it falls asleep. And so you can get an idea of how difficult it is, or how difficult it would be to move around and work around in the real world without your sense of touch. But this is what technology asks us to do all the time. Okay, so this is a representation of how your computer sees you, how your phone sees you. So we can have, just flat 2D vision with a single eye. Sometimes we get stereo audio through 2 ears, but we really only have one type of input through touch. So we have maybe, single input through touch on computer screens, type one key at a time on a keyboard. And there's very, very limited types of feedback through your computer. Sometimes you get some haptic feedback, like your phone will buzz if you get a phone call, or your gaming controller will rumble, if there's an explosion or you're driving on the side of the road in a driving game. So we do get maybe some type of haptic feedback or some type of touch feedback, but it's nowhere near as complex as what we experience in the real world. Because if this is how your computer sees you, this is how your senses are actually distributed. Okay, so this is what we call the sensory homunculus, or how the actual amount of brain power is distributed to each part of the body. So we can see the hands are really, really exaggerated. So we get a lot of touch information from the hands, which makes sense because we use our hands. They've evolved this way, for us to be able to use tools and to write and to really do fine manipulation of objects and pick things up. And we can see that, okay, the eyes are a little bit exaggerated. So we do get some information from eyes, lips, and tongue as well for tasting. But the amount of information we get from touch is just so huge, just so much brain power actually spent on processing this information. And so this is what we do in our lab, is study kind of how this touch information is processed in the body, and then how we can create artificial interactions through computers that can kind of fool you into thinking you're touching things that aren't there. And so this is the definition of haptics. And so our definition of haptics that we have in our lab is a touch-based interaction between an intelligent agent, which is you, and a real remote or virtual environment, which is going to be you interacting or touching with things in a computer, for example, in virtual reality or in gaming. So what we do in our lab is to create these devices and systems and algorithms, all these different things that allow you to actually trick the brain into thinking you're feeling things that aren't there. We have a specific focus on creating things that feel realistic. Okay, creating things that feel like what you would touch, what you would interact with in the real world. And so we bring in stuff from perception, creating devices, dealing with data, all together to create a sense of realism and immersiveness. So now I'm going to turn it over to my students, who are going to go more in depth about the type of projects and specific projects that we're working on in our labs. So fight on, and hope you enjoy the rest of your tour.
Hi. I hope you guys are having fun so far. I just wanted to give a little bit of a tour into what my day looked like as a researcher and a little bit of the work I'm doing. So I am a third year student for my PhD in the Department of Biomedical Engineering. I'm working on a project that goes between two different labs. So Heather's lab, the haptics lab, is one of them. And then I also work in a locomotor control and learning lab, which is part of a different department at USC. I'm really interested in assistive technologies and in building devices that can help people, especially people who have some type of physical disability or neurodegenerative disorder. So right now in my PhD, I'm doing a lot of learning still. I'm still a student. And so I would like to show you, this is kind of my desk, and I work here every day. This is my view. So right now I have on screen some notes. I just finished taking a class, and the class is on MATLAB. So here's my MATLAB code I'm working on. So I'll spend a lot of time learning how to write this and run it, and that way I can generate plots that look like this. Let me run this like that. I'm also in another class learning how to do programming with circuitry and boards. So over here, you'll see I have my electronics. I've kind of set up some makeshift storage and stations to work at since I don't go into the lab all the time. So that's been a change in my life because of coronavirus. However, I also do have days I go in that I may be collecting data during an experiment. So we have a human subject come in, and then we have different tools that we use to track them, record their data. And so part of my job is also looking at analysis of that data. Again, that's on the computer. So I go to a program like Visual 3D, and this is more common for the work I do in the stroke lab. But I may have work in this program that I'm running, and this is a program that would show me ways to measure walking. These are just some examples of different programs and softwares I've been learning this year and that I'm working with, and a little bit of what my work looks like. I also am designing an item, so some of those pieces are in the lab. I've been putting them in there slowly over the course of this year. And the item I'm designing is going to be a type of assistive technology. Right now, it might be a shoe, and I'll be able to make it feel like you're walking on sand when you wear this shoe. And the goal is to provide a surface that we can control so we can see how much it feels like sand versus how little it feels like sand. And that way, if someone's walking, we can control if they are walking on ground that's uneven, because sand is a ground that's uneven. So the motivation of my project is to have this shoe that feels like walking on sand that people with stroke can practice balance training on. That's because people who've had strokes have a lot of trouble walking, in particular on surfaces that are uneven like sand or like grass or like any other kind of like soft ground. And so rehab practices balance. In rehab, they practice balance. And so this could be a tool to help people practice balance, since there are not currently any wearable tools. All the tools are these big robots. They're pretty expensive. So this would give a different option that's a little bit cheaper, easier to move around. And that way, hopefully more people can get the chance to practice learning how to retrain their balance and how to walk again. So that's a little bit about my work. My name is Catherine Eunice. I hope you guys are getting something out of this. I wish we could meet in person, and hope we can do that soon. Bye.
Hey guys, I hope everyone's having a great robotics week so far. My name is Alex, and I'm a student researcher at USC. I'm an undergraduate student, and I really wanted to take this time to tell you a little bit about myself and my experiences as a student researcher at USC. So just a little bit about me. I'm originally from Columbus, Ohio, and I came out here to sunny Southern California to USC to study actually biology. But I found that once I got to college, I got a little bit more interested in computer science and electrical engineering, and I was really fascinated by how technology could be used to help improve the livelihoods of people who may suffer from conditions that may hinder the opportunities accessibility or inclusiveness that they may encounter. And so I was really interested in this topic and understanding how technology can be used to help people in difficult situations. And so I did a little bit of research in high school, actually in a biology lab. And so I had a little bit of experience with it coming into college. So I knew I kind of wanted to try it a little bit more. And once I got into college, I'd never done engineering research before. So I didn't really know what it was going to be like. But, I just thought it'd be a great thing to try. It couldn't hurt. And so I got involved with the Haptics, Robotics, and Virtual Interaction Lab, which is a group at USC on campus that does really, really cool research into a whole variety of areas. One being haptics, which is basically looks at how technology and touch can be integrated in order to increase the connectedness between people, would be an example. Virtual reality research. Yeah, I don't know if you guys may have seen the Oculus headsets before. Those are really, really cool, really fun. And also robotics research, so kind of looking at how humans and robots interact. And education has always been something that's been near and dear to my heart. I've always loved working with students. I've worked as a math instructor and tutor for kids in elementary school before, and so it was always an area I was really interested in. And so I was really interested in understanding how can technology be applied to education to help students who might not have the same level of access to educational materials. For example, for students who suffer from visual impairments, who, accessing their laptop, computer screen, or their phone, or dealing with, course materials and lessons that kind of may require elements of visualizing things, seeing pictures. Those things can be quite challenging for students who lack the ability to see. And so I got really interested in understanding how can I use technology to help. And so one way I did that and was able to kind of pursue that passion is doing research into a tool that can help students who are interested in understanding computer science and learning to code, developing a tool that is more easily accessible to students who suffer from some form of vision or sight impairment that makes it hard to see. And so at USC, I've had the opportunity with the Haptics Robotics and Virtual Interaction Lab to do research and to understand what aspects of education, specifically computer science education, so coding, might be easier for students who can use sight, and what aspects are more difficult for students who can't use sight. And along with this has really involved a lot of work into looking at ways to make a tool that can really make it easier for those students. And so it's been an opportunity for me to create a coding language, kind of like if you guys have ever heard of Java or Python or C++. These are kind of some popular languages that students learn to code in, to write code. And during my work at USC, I've had the opportunity to make a coding language that is based on touch rather than sight. So rather than using your computer to write code, you'd actually be able to use physical building blocks that you can touch and move around and arrange in all different ways to make computer code that you can actually run and see it do something. Maybe it could be make a buzzer beep a couple of times. It could be, spin a propeller a couple of times, things like that. But really trying to remove the element of sight from coding so that a student who doesn't have full use of their vision could actually be able to write code and learn the important foundational concepts of coding and programming. And so doing research at USC has really just opened my eyes to such a unique and powerful opportunity to be able to do work that I hope can help make a change. And that's why I love research. And I hope you guys found this helpful if research is something that you're thinking about. And I wish you all the best of luck. And I hope you have a great rest of Robotics Week. Bye, guys.
Hello. Hi, my name is Sandeep. I am a second-year PhD student in the HARVI lab. HARVI stands for Haptics, Robotics, and Virtual Interaction. In our lab, directed by Dr. Heather Culbertson, we tend to explore ways to improve virtual interaction. That is including virtual reality, gaming devices, things like medical research as well as other kind of simulations that we can possibly do and how we can improve it using haptic or robotic technologies. In particular, in my research, I tend to focus on some thing called Vibrotactile Haptics. You might be wondering what Vibrotactile Haptics is. All of you have experienced Vibrotactile Haptics in one way or another. If you recollect, your phone is one of the best examples that I can tell you about a system that uses Vibrotactile Haptics. For example, your iPhone or your Android phone tends to vibrate the moment that you get a notification, or your MacBook touchpad tends to give a fake virtual click when you click on some object. All of these are provided by haptic technology. In these kind of haptic technology, we tend to use signals, electronic signals, to control how vibration are induced in different components, thereby transmitting it to you, and you tend to represent and understand that as a click. So in my project, I am focusing on trying to create a glove with several vibrotactile haptic devices. So your phone tends to have one haptic device. So I am trying to do a lot of haptic actuators, namely 40 or 80 haptic actuators on your hand, each one spaced accordingly. So imagine that you are holding a ball. You can feel the ball in your hand, and you can feel it roll around in your hand. You can squeeze it, you can feel that. So how would you feel such a ball in virtual reality? That is what I am trying to explore with my research. With my research, I tend to explore a whole lot of different parts of different fields. This might be overwhelming at first. It was really overwhelming for me. And then as days go by, I've had an opportunity to explore and learn as I go with my projects. So for example, I have been delving into electronic design, prototyping boards like these, in which I have done the complete design. I have actually set it up to work for whatever product or project that I'm trying to make. Similarly, I have been working on prototyping physical artifacts. For example, like the glove model that I've been talking about, and other components to go along with electronics so that I can further progress in my project. Another interesting component that I work on is mainly computer science. There's a lot of programming to do when you try to interact all of these different components and make it into one cohesive unit. Along with that, we tend to use psychology and psychometric functions to test our devices and our devices' capability and how well our devices are performing in virtual experiences. That is about my project, and I will show a little bit of my desk, and I'll show what I'm trying to work on. So, at my desk, you can see there are a lot of wires, a lot of components, a lot of things that are happening here. So, if you look at this, I am designing a board. The board that I showed you, I'm trying to make the next version of it. And this is the prototyping area where I'm trying to understand different components of what I am trying to do. So this is a power supply that I've made, which works onto a board, and then a lot of control system and control wiring. Although I'm not going to show you the code, which might be a little bit overwhelming for the time being. And also this is to test the signal which is coming out from the boards. So that is pretty much what my day looks like. I try to dabble in different technologies, try to make it work. And although I'm not a big fan of all these wires in here, I try to compress them and make it into beautiful drawing like this and make boards like this so that I can just get rid of all the wires and it'll be a neat little box. Thank you. In our lab, we also work with small haptic robots. This is the Geomagic touch, or right now called 3D Systems touch device. So it may not be a very good demo to show across video, but I'll try to show regardless. So in this demo, what we have here is a virtual dice, and you can see this is represented by a ball here, and you can see that I'm unable to move when I reach the floor, so I get stuck there. So that I can feel the virtual floor, and then similarly I can move these boxes around. And it kind of represents the force, what is required. So this is a very heavy box. It takes a lot of effort to move, whereas this one is lighter and I can move it easier. So that is the demo for Haptic Robots, and this is one of the tools that we use in our lab. Now, as I said earlier, we also do a lot of prototyping. This is all our tools that we have right now that we use to create physical prototypes. And this is our printing section where we have different kind of printers. That's a normal printer, by the way. And we have 2 3D printers. And I believe somebody is printing something for their project. So you can see that in our lab, we tend to play around with different objects, different materials, electronics, mechanical engineering, and prototyping to make beautiful objects and test them out in the real world. Thank you.
Hi everyone, my name is Ying Chen. I'm a first year PhD student in Professor Heather Culbertson's lab. As you all probably heard from my other lab mates already, we're a lab that studies through the usage of robotics, how to provide haptics feedback, which is the sensation of touch, to the users. And my research topic in recent years has been mainly focused on haptic tactile, such as pen array displays, or virtuality related. And the project I want to show you guys today is a virtual reality project that I've been working on in the past year. Generally, I don't know if you all have heard of it, but virtuality has become more popular in the recent years. And generally the usage of it is where you wear this goggle, and through the goggle it displays a virtual environment to you, and you can navigate, move around, and then even interact with some of the objects that's within the virtual world. However, one of the limitations of existing virtual reality headset is that there is a nauseousness created when users started to use this headsets for too long, because mainly the reason is because you get this unmatching movements, pattern, feedbacks to the different users. You see yourself moving in virtuality, but you don't really feel yourself moving in the real world accordingly, or your speed of movements doesn't match up between the virtuality and your real world. So this sort of disorientation started causing sickness for different type of users, and are limiting people from using these headsets for long. And in my research, I'm trying to create a new type of virtuality and navigation controllers. I want to show you some of the existing ways of how does people actually navigate, which is how to move around in virtuality world. So the most common way right now is to use this type of controllers, which you can see on top of it, it has a joystick controller. And generally when you are trying to move, you just press forward, left, forward, back, left, right. You want to move in the coordinated directions in the virtuality world. There are also a very common way in virtuality, which is to use teleportations. So essentially what it is you point this thing at a location in virtuality that you want to go, and you press a button, and basically after a short wait, it basically teleports you to the new location. However, most of the methods are still causing nauseousness, especially with the joystick one. The main reason is because, like I said, the unmatching patterns of what you are seeing comparing to what your other part of the body are actually feeling. You are seeing yourself moving in a direction, but your body is telling you, no, you're stationary. And when this sort of disorientation happens, you start feeling sick and wanting to puke. So one of the projects that I've been working on recently is to use this, which is a Weeboard. Essentially it is a center of gravity recording device. Basically what that means is when you're standing on top of this piece of board, I can know exactly where your center of gravity are relatively to these 4 corners. I can know whether you're leaning forward, leaning backward, leaning to the left, or leaning to the right. And basically, we incorporated this to the control of some of the existing games in Virtuality. And right now, we're using it in my own game, which is a carding game that I designed with Unity. And generally, what is happening right now is that instead of using the joystick to control the car to move around, you stand on this piece of board, or you sit somewhere and then put your feet on this piece of board and control the movements in Virtuality by shifting your center of gravity, which is by leaning. And in addition to that, we also added in two exciter speaker here, as you see, to provide haptic feedback to users when they are exploring the VR world. We are hoping that this can create a more comprehensive experience, or more matching patterns or matching signals that your body are receiving in order to mitigate some of the effects of virtuality sickness. So one of my the current system setup is basically where you drive the car in virtuality by leaning, and then as you're going through some of the bumps, or as you're driving on the road, you can feel the vibration from the engines as well as from the bumps if you're driving over one. And then we're about to conduct a user study in the summer, and then I'm looking forward to see what the results are. So yeah, this is mainly my research. I hope this sounds interesting to you guys, and if any of you are interested in more information about my research, please feel free to reach out to us or our lab.
Hello everyone, my name is Ying. I'm a second year PhD student at HARVI lab. The project I'm working on is a wearable device for social communication. Can we touch friends remotely? So we create this device. Once we touch on this sleeve, the actuator sleeve can generate different gestures such as stroking, squeezing, patting, poking, etc. So later on, I will show you how these actuators inside the sleeve moved to generate these gestures. If you have any questions, feel free to let me know, and hope you enjoyed this video. Thank you.